I'm going to do a really quick demo, hopefully it's quick, of two new modules that I've been working on. They are Dagger AWS and Dagger GCP. So I'm working on integrating Dagger more closely with the major cloud providers. Now, the motivation for these modules, or at least the initial use case for the modules, is to make it easier to push container images into those clouds. At the moment, if you want to push container images into those clouds using Dagger, you can do that with the publish command, but it requires that you've set up the auth helpers and set up service accounts and basically done a lot of fiddling around and clicking in order to set that up. So these modules aim to make that a lot more of a streamlined process. And so all you need is either the credentials.db file that you have locally from Google Cloud, or similarly the AWS credentials file that you might have locally on disk in the case of AWS. So what I'm going to do in this demo is I'm going to push the same container image to both clouds at the same time. And so what we can do is we can have a cloud race. So count me down, 3, 2, 1. Okay, so we're going to race AWS and Google Cloud. So what this is doing is it's pulling down the latest CLI container images for each cloud. And then inside those CLI container images, it's mounting the credentials file. Oh, and we have a winner. AWS is the winner. And it's mounting the credentials files into the container images there. And what you can see, oh, I should have showed you this first. We had two empty repositories in both the Amazon Elastic Container Registry and the Google Artifact Registry. And so if I reload these pages, you'll see now that the container image that I pushed that wasn't there before is now there. So we can see the latest tag in Elastic Container Registry, and we can see this latest tag here on Google Cloud. So that's it, really. It's a super quick demo. I will just very briefly talk about the implementation in case that's interesting to people. So you can see just in terms of number of lines of code, the Google implementation was quite a lot harder than the AWS implementation. The reason for that is that AWS has this nice get login password command as part of its CLI. Whereas with Google, what you have to do is lots of things. You have to start by creating a new service account and then add an IAM policy binding for that service account. And then you have to create a new key for that service account. And we have to handle the case where that thing does or doesn't exist already. And then you use that service account and base64 encode it, as I'm sure people are familiar with, and then do with registry auth with the base64 encoded key from that service account. There is one nice thing about this feature, though, which is that in terms of the Google Cloud integration, which is that we create a brand new service account key for every push, and then we delete that service account key after the push. So that's quite secure because the key only exists for the duration of the push. And actually, I forget who it was, but someone else mentioned earlier in the call, it's really nice to be able to use defers. Well, I had exactly the same realization in Go, that it was really nice to be able to say defer, clean up my service account key. So even if something in here panics, I'm still going to get that service account key cleaned up. So yeah, that's my demo. Both of these modules are available on the Daggerverse. Just look for Dagger GCP and Dagger AWS. I'll be adding documentation and tidying them up a bit in the coming days and weeks. Yeah, any questions, please drop them in the chat. That's everything I've got.
Thanks. This is very cool. And I realized awesome. when I did your intro, I was like AI demo because I'm so used to you doing very specific AI ones. I completely forgot this is but this is honestly so cool. It's fun to see the
That's
race.
totally fine. Yeah, for once I'm not bringing an AI demo, although I think I might be bringing an AI demo to the next one. We'll see.
Solomon actually asked in here, and feel free to unmute if you want to follow up, Solomon, we have time. But the question was, does this include all necessary infra provisioning, like zero to deploy?
Does it include all necessary infra provisioning? No. So it currently assumes that the user has created the container registry in the cloud, or that it already exists from something. It wouldn't be that hard to make it automatically create those if necessary. I kind of wanted to scope down the permissions that you needed to use it. But I think that might be one of those things where we can check if it doesn't exist, and if it doesn't exist, then we can try and create it on demand. So yeah, and I think as these integrations with the clouds grow, this is just like this is kind of day one for them. But I think as they grow, it would make sense to bite off more and more of that kind of infrastructure provisioning piece, kind of on demand as necessary. Yeah.
And then comparisons with, this with like Terraform and Pulumi, do you have any thoughts specifically on that?
Yeah, great question. So as I was building the Google Cloud integration and I was writing all the code to reconcile a desired state with an actual state in a cloud provider, I was like, this feels very Terraform-y. I've dealt with Terraform a lot in the past. And I did feel a bit like I would ideally not be writing all that reconciliation code for like a hard-coded desired state in the code by shelling out to the gcloud command and like handling all the edge cases of the different ways that like the gcloud CLI returns errors or like not exists, or in some cases always says permission denied even if it doesn't exist and things like that. And I thought, well, Terraform and the like have already dealt with all of those edge cases. So actually what I'd really like to do is there's an existing Terraform module in the Daggerverse, and I'd like to try and implement or re-implement my GCP module in terms of the existing Terraform module, and therefore delete some complexity from my code, which is always nice. And the other thing that I'd be interested in layering on top of that, or maybe we use Pulumi or something. I haven't really looked into this very much yet, but what I'd really like to be able to do is express the desired state as Go code in the in the code, in the Dagger code, rather than having the Dagger code come with like a pre-baked like Terraform config in a string in the Go code or something. I'd like to be able to express it as Go code, and then just say, hey, reconcile against this kind of desired state expressed as code. So infrastructure as code that is actually code or something like that. But yeah.
I love that. In that last option, it seems like it's still possible to wrap actual Terraform or actual Pulumi under the hood, right? Just expose it in a more Dagger native way. I love that.
Exactly. I'd like to avoid having to rewrite all of the complexity inside Terraform and all the different Terraform modules for all the different clouds, because that does wrap an awful lot of complexity. And like I was saying before, there's a big surface area there. So yeah, let's just wrap it and expose a nicer UI properly.